So, ladies and gentlemen, we are saying that a limit is the value that a function will approach as its input approaches some value. And we are saying the formally putting this mathematically, we are saying that limit of a function will be if I limit this function as the input of the function here is x. So as x approaches c, this function is equal to L. That means the limit of this function as x tends to c is L. So we are saying if I have f of x equal to x squared, for example, plus 1, and I want to find the limit of this function as x tends to 1, I'm saying limit of this function as x tends to 1, so limit of x squared plus 1 as x tends to 1 will be, I'm limiting this value of x to be 1. So that means I'm going to substitute in 1. So 1 plus 1, remember this is 1 squared plus 1, this gives us 2. So limit of this function, okay, the value of this function as x tends to 1 is equal to 2. And therefore 2 becomes the limit of this function as x tends to 1. So the limit of f of x as x tends to 1 is equal to 2. That's what we are meaning. So this means that as x approaches c, the function f of x approaches the value L. That's what we are basically talking about here in this example. That as x, the input of this function or the index of this function, as that value x tends to 1, then the value of the function itself tends to 2. And we have seen that by just substituting directly where x is. We have seen that 1 squared plus 1 will give us 2, and 2 becomes the limit of the function as x tends to 1. So we have types of limits, and we have left-hand limit and what we also call the right-hand limit. So the left-hand limit is that we are approaching the function f of x, okay, with the x tending to negative c. That means we are approaching it from the right. So we are approaching from the right, and that becomes the left-hand limit. If we approach it from the left, that becomes the right-hand limit. In other words, we see that limiting the function f of x as x tends to positive c would give you a right-hand limit, and we are approaching it from the left. I'm saying if you have a function f of x and these are x values, if I'm approaching a particular value c, okay, the value the c, the value of c could be somewhere there. So if I'm approaching it from the right, okay, I'm approaching, this is c, I'm approaching c from the right, this becomes the left hand limit, because c is being approached from positive going to negative. So the arrow is pointed to the negative. That's why it becomes, in other words, to the negative side of x values, where we find that the negative x values are on the left hand side. And therefore, that's why we call it the left hand right. And we approach that value from the right. Now, if we are saying c, x is tending to c positive, then we are approaching it from the left. And that means we are going to be having the right hand limit. So that must stick in our minds. Then limit rules, we shall see that if we limit two functions, for example, we have a function f of x plus g of x, okay, as x tends to c, okay, is the same as limiting this function alone, f of x, okay, plus limiting this function g of x alone as x tends to c. E.g., I can say my f of x is maybe x plus 1, okay? And g of x is equal to, let me say, 2x squared plus 1. Now, if I'm to limiting, remember I have x plus 1, okay? Then plus 2x squared plus 1 as maybe x tends to 1 will be the same as if I limited each of these components. So it will be the same as limiting x plus 1 as x tends to 1 plus limiting 2x squared plus 1 as x tends to 1. That's what we are saying. So when you look at this, this will be what? This will be, this is going to be 1 plus 1, that is 2. Then this is going to be 2 plus 1, which is 3. And this is giving us 5. Now, let us see if we did the same for this. So this would give us a limiting 2x squared plus x plus 2. So if we substitute in 1, does it give us 5? This would be 2 times 1 squared, which is 2 plus 1, then plus 2, and this would also give us 5.
Actually, Mr. The screen is not, we are not seeing the screen.
So that is it. So that's all about limits. And the other rules are also true. As you can see, limit of, if I have a product of two functions, so limiting the product of the two functions, okay, will be the same as limiting one function, then I multiply limiting the other function, or limit of the other function as x tends to c, I multiply by limit of another function as x tends to c. Then we have also the quotient rule where we are dividing functions. So if I take the limit of the function as x tends to c and I divide it by another a limit of another function as x tends to c, then provided that g of x, this one which is at the bottom, the denominator, is not equal to 0, then this will always equal to if I limited these two functions divided by each other as x tends to c. So that's all about limits, actually in summary, but we shall look at it as we also move on. So having looked at the limits, we need to also talk about continuity of a function. So continuity of a function is defined in such a way that a function is said to be continuous if it has no breaks, jumps, or holes at a point x is equal to c, and the value of the function matches the limit. The function is said to be continuous if it has no breaks, okay, If you have a function of this nature, you have a function that comes like this and then starts from somewhere. So that function is not continuous because there is a break. There is a break there. Another function, if you have a jump, okay, it could come like this and suddenly gets a jump. It is not, there is nothing to join this and this, so this is an empty space, and that is not a continuous function. If a function is like this, and there is a hole there, the function is continuing that side and also the other side, then this function is not continuous. Okay? That is if we are talking about a point x is equal to c. This could be a point x is equal to c. This could be a point x is equal to c. This could be a point x is equal to c. And if at point c the function has a break, if at point c the function has a hole, if at point c the function has a jump, then we will say that function is not continuous at C. Now, if it is continuous, there are no breaks, no holes, no jumps. And then limiting that function as x tends to C will give you the function, the value of the function at point C. I don't know if this can be clear. If I say I have a function 2x squared, f of x is equal to this, maybe plus 1. If I say the function is continuous at x is equal to, for example, 2, that means there is no what? There is no break at that point. So for example, if you substituted, if I substituted, for example, if I say limit, okay, let me first take a limit of 2x squared plus 1 as x tends to 2. This will be 2 squared times 2, that is 4 times 2, that is 8 plus that. This gives us 9. If it gives us 9, what is f of 2? Is it also equal to 9? So if it is equal to 9, then that function is continuous at x is equal to 2. I repeat, a function is said to be continuous at x is equal to c if limit of that function as x tends to c is equal to the value of that function at x is equal to c. So if that one is clear, we can talk about the types of continuity. So we have continuous when the function is continuous everywhere, and if we are talking about the function being continuous at all points in its domain, if we have the domain of the function as 0 less or equal to x less equal to 2, and all over all these values from 0 to 2, the function is continuous, then we shall say it is continuous everywhere. Or if we picked a value like 1, okay, and we got the value of the function at x is equal to 1, okay, if we get it and we find that value is equal to limiting the function as x tends to that value x is equal to 1, then we shall say the function is continuous at that point. But if we pick, if we want to show that this function is continuous everywhere, then at each of all these points in the domain we are meaning the range of values of x. This is the domain. If we are talking about range, the range of a function, we are talking about f of 0 less or equal to f of x less or equal to f of 2. So the range we are talking about the values, the limits within which the values of f of x lie from 0 to 2. That's the range. Now the domain is the range of values of x. So if the function is continuous all over the domain, okay, then we shall say it is continuous everywhere. Then another type of continuity is when you have the function discontinuous. The function has points where it is not continuous. In other words, it has holes, it has jumps. So if it is not continuous or it is discontinuous, then it will have certain points where it is not continuous, such as holes, jumps, or breaks. So the key properties we need to understand that the function is continuous at x is equal to c if limiting that function as x tends to c exists and it is equal to f of c, or f of c also exists, and therefore if I connect 1 and 2, then I'll have 3, whereby limiting that function as x tends to c is equal to the value of the function at x is equal to c. The types of discontinuities, you can have a removable discontinuity, a hole in the graph where the function can be redefined to make it continuous, like you can fill up that hole and the whole thing becomes continuous. A shomer of a wire that has been moving, and all of a sudden there is a gap. In between there is no flow of current, okay? There is no flow of current. Of course, in certain circumstances, you will have no, okay, in most scenarios you have no current because air occupies here, and the air we know is an insulator or is a bad conductor of electricity. So we are saying if it is removable, then that means we can connect a wire there and remove that discontinuity. So that's what we are talking about, a removable one. Then a jump, the function will have different limits from left and the right sides at a point. Then if a discontinuity is infinite, then the function approaches infinity at a particular point. So evaluate the following limits. Limit as x tends to infinity of 4 minus 3 out of x squared. So now, to deal with this, we are going to, as an infinity, as we tend x to infinity, what is the value of this function? So now this is the same as limiting x to infinity for 4 minus, even if we divided this by, okay, let's divide throughout by x squared. So we'll have 3 divided by x squared out of x squared divided by x squared. So we are saying here, divide throughout by x squared. Okay. So limit as x tends to infinity, okay, 4 minus 3 out of x squared divided by 1. So put in now, substitute x is equal to infinity. Put in a very big value. If you substitute in a very big value, okay, what will it be? You'll find that this limit as x tends to infinity of 4 minus 3 out of that big value squared divided by 1, this will be 4 minus 0, and this will result into 4. So whenever you have such a scenario, first divide throughout here by the biggest of this unknown, and then you will proceed. When you put in the value of x here, it will give you the value of the limit, and that will make the life of yours very simple. Another example for limits. So here we have this example. So what we do, we also divide throughout by x squared. So divide throughout by x squared, because x squared is the largest is the largest component, or is the component that has the largest power. So if we substitute it in here, what will it be? So limit as x tends to infinity of 2x divided by x squared plus 1 divided by x squared divided by x squared out of x squared plus 4 out of x. So this doesn't change anything. So this is going to be, this is the same as limit as x tends to infinity of 2 out of x plus 1 out of x squared, okay, divided by, this is going to be 1 plus 4 out of x squared. So what is this going to give us? So if I put in x, so substitute x is equal to infinity. So what will that be? Limit of this function as x tends to infinity. So this will be 2 out of infinity plus 1 out of infinity squared divided by 1 plus 4 out of infinity squared. So this becomes 0, this becomes 0, this becomes 0, and this is going to give us this is going to give us 0 divided by 1 plus 0, so which gives us 0. So this is going to be infinity. 4 divided by infinity is 0. 2 divided by infinity is divided by a very huge value. This is 0. 1 divided by a very huge value. Infinity means a very, very big value. So get like 1 divided by like 100 to the power 30. You'll find that that is a very big value, and therefore when you get 1 divided by that value, you get 0. 2 divided by, for example, 100 to the power 40, you also find it is giving you 0. The same thing, so this is 0 plus 1, remain with 1. Above you have 0. This gives you the final answer. So in here, you also divide up and down by x. So you have limit as x tends to infinity of 2x divided by x plus 1 out of x divided by x divided by x plus 4 out of x. So here this becomes limit as x tends to infinity of 2, okay, plus 1 out of x divided by 1, okay. So I can say this is divided by infinity divided by 1 plus 4 out of it. So this becomes 0, this becomes 0, and you'll have 2 out of 1. Finally, limit as x tends to infinity of 2x plus 1 divided by x plus 4 gives you 2.